Setting up an environment for a job run is a critical step in the machine learning lifecycle. It ensures that the model runs efficiently and effectively in a production setting. This process involves configuring hardware, software, and other resources to meet the specific needs of the job. In this presentation, we will delve into the various aspects of environment configuration, including selecting the right infrastructure, installing necessary libraries, and optimizing settings for performance. By the end of this session, you will have a comprehensive understanding of how to prepare an environment that supports seamless job execution. Before configuring an environment, it's essential to understand the specific requirements of the job. This includes the type of model being deployed, the data it will process, and the expected workload. For instance, a deep learning model may require GPUs for faster computation, while a simpler model might run efficiently on a CPU. Additionally, consider the data storage needs, network bandwidth, and any dependencies the job might have. Understanding these requirements helps in selecting the appropriate resources and configurations, ensuring that the job runs smoothly and efficiently. Choosing the right infrastructure is a crucial step in environment configuration. Depending on the job's requirements, you might opt for on-premises servers, cloud-based solutions, or a hybrid approach. Cloud platforms like Azure, AWS, and Google Cloud offer scalable resources that can be tailored to your needs. For instance, Azure Machine Learning provides various compute options, including CPU and GPU clusters, which can be easily scaled up or down. On-premises solutions might be more cost-effective for long-term projects with stable resource needs. The key is to balance cost, performance, and scalability to meet the job's demands. Once the infrastructure is in place, the next step is to install the necessary libraries and dependencies. This includes machine learning frameworks like TensorFlow, PyTorch, or scikit-learn, as well as any other libraries required by the job. Using package managers like pip or conda can simplify this process. It's also important to ensure that all dependencies are compatible with each other and with the underlying hardware. Creating a virtual environment can help manage these dependencies and avoid conflicts. Documenting the installation process ensures that the environment can be easily replicated or updated in the future. Configuring software settings is another critical aspect of environment setup. This includes setting environment variables, configuring network settings, and optimizing software for performance. For example, you might need to set environment variables to specify the location of data files or to configure the behavior of certain libraries. Network settings might need to be adjusted to ensure that the job can access necessary resources without latency issues. Performance optimization can involve tuning parameters like batch size, learning rate, and memory allocation. Properly configured software settings can significantly enhance the efficiency and reliability of the job run. Effective data storage and management are vital for a successful job run. Depending on the job's requirements, you might need to set up databases, data lakes, or file storage systems. Cloud storage solutions like Azure Blob Storage or AWS S3 offer scalable and secure options for storing large data sets. It's also important to consider data access patterns and optimize storage for performance. For instance, frequently accessed data might be stored in faster, more expensive storage, while less frequently accessed data can be archived in cheaper, slower storage. Implementing proper data management practices ensures that the job has quick and reliable access to the data it needs. Security and compliance are critical considerations when configuring an environment for a job run. This involves setting up access controls, encrypting data, and ensuring compliance with relevant regulations. For instance, you might need to implement role-based access control, RBAC, to restrict access to sensitive data and resources. Encrypting data at rest and in transit helps protect it from unauthorized access. Additionally, you must ensure that the environment complies with regulations like GDPR, HIPAA, or CCPA, depending on the nature of the data and the job. Implementing robust security measures helps protect the integrity and confidentiality of the job and its data. Monitoring and logging are essential for maintaining the health and performance of the environment. Setting up monitoring tools allows you to track resource usage, detect anomalies, and identify potential issues before they become critical. Tools like Azure Monitor, AWS CloudWatch or Prometheus can provide real-time insights into the environment's performance. Logging is equally important, as it provides a record of events and actions taken during the job run. This can be invaluable for debugging and auditing purposes. Implementing comprehensive monitoring and logging practices ensures that you can maintain a stable and efficient environment for your job runs. Optimizing performance is a key aspect of configuring an environment for a job run. This involves fine-tuning various parameters and settings to ensure that the job runs as efficiently as possible. For instance, you might need to adjust the number of parallel processes, optimize memory usage, or fine-tune the model's hyperparameters. Profiling tools can help identify bottlenecks and areas for improvement. Additionally, implementing caching strategies can reduce redundant computations and speed up data access. By continuously monitoring and optimizing performance, you can ensure that the job runs smoothly and meets its performance targets. Before deploying the job, it's crucial to thoroughly test the environment to ensure that everything is configured correctly. This involves running test jobs and validating that they complete successfully without errors. Testing helps identify any configuration issues, compatibility problems, or performance bottlenecks that need to be addressed. It's also important to test the environment under different conditions, such as varying workloads or data sizes, to ensure that it can handle the job's requirements. Thorough testing provides confidence that the environment is ready for production and can support the job run effectively. Automating the environment setup process can save time and reduce the risk of errors. Tools like Terraform, Ansible, or Azure Resource Manager templates can be used to automate the provisioning and configuration of resources. Automation scripts can ensure that the environment is set up consistently and can be easily replicated or scaled as needed. Additionally, using version control for your automation scripts allows you to track changes and roll back to previous configurations if necessary. Implementing automation not only streamlines the setup process, but also enhances the reliability and maintainability of the environment. Documenting the environment configuration is essential for maintaining and troubleshooting the setup. This includes detailed records of the infrastructure, installed libraries, software settings, and any custom configurations. Documentation should also cover the steps for setting up and testing the environment, as well as any known issues and their resolutions. Keeping comprehensive documentation ensures that team members can understand and replicate the environment if needed. It also serves as a valuable reference for future updates or changes. Proper documentation enhances the transparency and maintainability of the environment, ensuring that it can support the job run effectively over time. To illustrate the process of configuring an environment for a job run, let's look at a real-world example. Imagine a company deploying a machine learning model to predict customer churn. The model requires a GPU for training, a large dataset stored in Azure Blob Storage, and several Python libraries. The team selects Azure Machine Learning for its scalable compute options and sets up a virtual environment to manage dependencies. They configure network settings to ensure low-latency data access and implement monitoring with Azure Monitor. After thorough testing and performance optimization, the environment is automated using Azure Resource Manager templates. Comprehensive documentation ensures that the setup can be easily replicated and maintained. Configuring an environment for a job run is a multifaceted process that requires careful planning and execution. By understanding the job's requirements, selecting the right infrastructure, installing necessary libraries, and optimizing settings, you can create an environment that supports efficient and reliable job execution. Additionally, implementing security measures, monitoring, and automation enhances the stability and maintainability of the setup. Thorough testing and documentation ensure that the environment is ready for production and can be easily managed over time. By following these best practices, you can ensure that your job runs smoothly and meets its performance and reliability targets.